Hey guys, it's IDW, and today we're going to be doing a quick little video about block update detectors for my memory series. Because block update detectors are actually, if you think about it, one of the most useful things that you could possibly hope to make with redstone in terms of memory. So what I mean by this is, let's look at the state of this piston right here. If I change this value right here permanently, it's not going to affect this piston unless it's on and I give it a block update, and then unless I give it another block update, it's going to hold that state forever. This right here, if we just make it so that we have something that can update this block, like say a normal piston, let's just get rid of the sticky piston for now. If we just get something that can update it like that, then we could potentially make something that works in a similar way to RAM using a block update detector. So yeah, so basically we're going to say that this is the write command because it's the thing that's going to update the block. And then down here we're going to have the output of this, and this is going to be acting like a gated D latch, aka D flip-flop. And actually that lever is going to power through, so I'm going to need to put it here. So as you can see, flipping this lever, nothing's happening. Flip this lever, and it sets it to whatever value is in this guy right here when I flip the lever. So for instance, if I was to set it to 1 again, then it would still remain as a 1. But if I was to set it to 0, then it would update it and it would turn into a 0. And no matter what I did, it would still remain the same. And if I was to write a 0, then it would just, what? Oh yeah, that's just because you want to put a slab here just so that that doesn't happen. You can't actually power the piston with a design like this. But yeah. So that's basically what piston-based RAM, basically how it works. At least the logic behind it. And I actually have a pretty good design for memory that implements this up my sleeve. So yeah, I think I'm going to show it off in this episode, so see you guys in a second. Okay, so just like my, instant carry adder design, this one I actually designed because I wanted to have a dual read memory system that would read out onto 2 buses that were arranged in AB-AB manner. So this memory design actually goes really well with that adder design, so I thought I might as well say that right now, just because they were sort of built. I built them at almost the exact same time, and they just work together really well. So yeah, so the first thing that we're going to do is we're going to take this and we're going to put 2 blocks right here. And if we remove, and let's say that this block's attached to a piston. If that piston retracts, then we can, then it will read out. So basically, that's exactly what I'm going to do. And yeah, so I'm just going to take a piston, like that. And yeah, so first of all, the first thing that we're going to want to do is we're going to want to have this piston extended whenever, oh yes, and we need to put another piston here just to power this block. And if you think about it, actually at this point, if we have our redstone block right here, then that can just be the bud memory, and that's exactly how stuff's going to work out. But in the meantime, as you can see right here, if we just attach a wire to that, then we can actually power this line, and we'll make it so that regardless of whether this is extended or retracted, we can make it so that this will constantly output 0, which is what we want to do when we're not reading. When we are reading, though, we're going to want to actually make it so that it depends on this redstone block value. And also we're going to have make sure that our 2 read commands don't conflict. So we're going to have 2 carry lines. Well, not carry lines, but read commands. One to read from in one direction and the other to read in the other direction. So as you can see, because we have a slab, this right here, this block will get powered and this block won't. And this block will get powered by this line and this block and this piston won't. So yeah, that's basically why I have those slabs here. But this comes up with a bit of an issue, and that is that with this situation right here, we actually have to have the signal go in one direction. It can't actually flow back over this slab since it's moving downwards, and we can't do something like this just because then it will conflict with the redstone block when it's extended. So yeah, basically we're going to have one read on this side of the memory and the other read come out from this side of the memory. So yeah, that's a few of the design flaws with this thing, but otherwise it's really straightforward and just a really good build in general. Also, we're going to need to have our input inverted just because the 0 state is actually going to have to be the piston extended, since if you look at this design right here, we have these two pistons. The only time that they're not going to send the signal through is when this piston is extended and this right here is off. So basically what that means is that this redstone block, when it's saving a 0, is going to have to be here, and it's going to have to be retracted when we're actually saving a 1. So right now it would be saving a 1 into the memory. So yeah. This will need, the input will actually need to be inverted, is basically what I'm saying. Okay, so then you're going to want to bring your wire along like that, just because this will make it so that it can tile perfectly. And actually, now that I think of it, I should probably remove these guys from this side and move them onto this side, just so that this will tile perfectly with this up here. And then up here, just have to take our piston and just extend this wire all the way through. And that right there is this memory cell completed. All we need to do is invert both of these inputs, which I'm going to do actually after I stack this. But yeah. So let's just make 4 bits worth of this. And then let's, oh dear. My bad. I'm derping out with world edit again. Yes, I know. And let's make 3 memory addresses. Why not? So now we're just going to have to power this guy right here like that. And power this guy like that. So that we're not constantly reading. So basically all we're going to have to end up doing is we're going to have to invert all these inputs, and we're also going to have to invert these top wires. But yeah, otherwise we don't need to invert anything. So I'm just going to do that off camera, and I'll see you guys in a second, and I can actually demonstrate this memory. And we are back. As you can see, I have built all the inverters in. I've also actually added glowstone lamps down here, just so that it's going to be easier to see how this stuff reads out. And I've forgotten to put levers on these guys. So basically, now we're just going to have to test this thing out and see if it works. It should work unless I've derped out in some design part of this. But yeah, I'm pretty sure I haven't. So let's just say, let's save an 11 to our first memory slot. Let's save a 3 to our second one. Five to our third one. And a 1 to our last one. So yeah, this right here should potentially, well, should actually have the whole thing working. So let's read on the first bus our first value, which was an 11. Ta-da! It's our 11 reading out. Now let's read on the other bus our 1, and then this could go into our adder, and we could add 11 plus 1, our classic addition sequence. And for some reason it's not reading, and that's just because of signal strength. Yeah. One should really put repeaters on every single one of these buses, but for the moment I'm just going to put them on this one because it's the only one that we need to see. So as you can see on the bottom bus, we're getting a 1. And yeah. So now let's read 5 from this bus. Actually, that's where I saved the 3. And so now you can see it's reading out the 3. If we were to read the 5 onto this bus, then we would get, oh no, that's the 3 that I'm reading out, not the 5 that I have saved. Ta-da! So everything is working just fine, and I have not derped out. So yeah, I hope that this design has helped you. It's a really nice design. Hope you've learned enough about piston-based memory to maybe make a better design than this. It's a bit difficult, but it's definitely possible. But yeah, see you guys next time. Oh, and I forgot to mention, that ends this entire series, so yeah, bye!